Today's video, we're going to learn about the multimeter and how it works, as well as how the breadboard works. We're going to use the multimeter in order to understand how the breadboard works. So let's first talk about what a multimeter is. So a multimeter is a tool used in industry, and by name, it measures multiple things, multimeter. So if you're looking at the multimeter, you can see that it's measuring current, voltage, it tests batteries, it tests continuity, it can test diodes, and so it also can test resistance. It measures resistance. So it's a useful tool that allows us to measure multiple things that are related to electricity. So included with your multimeter were some leads, and you can see that your leads are plugged into the different jacks that are down here at the bottom of the multimeter. I'll go into more detail about each one in a minute, but what I want to point out is that your multimeter came with the leads like this, and so I already took the cap off of this one. You'll want to take the cap off of these whenever you use these probes in order to measure different electrical components, because you need to touch metal to metal, so make sure you don't leave the caps on. But what I will recommend to you all is that we switch out these probes. So these probes are really good. These are good when you're needing to hold onto it, make sure it's making good contact, and you're measuring it using your hands. But if you want hands-free, and we'll actually do that a lot because we're going to measure different components across different electrical components, and we want to be able to connect it, look at the meter, write it down, kind of be hands-free, I recommend using the other leads that came in your kit. So these leads right here, this is what we call our pincher leads. And so you can see right here, it has these little springs, and it releases this little hook, and so you're able to hook that onto a wire. So I recommend doing that first and using these instead of the ones that come with the multimeter. So if we're looking more closely at this multimeter, you can see that there's 3 jacks that those leads that I showed you can plug into. This one right here has a red circle, and it has labeled many different things. It has volts, ohms, milliamps, bat, something that looks like a Wi-Fi symbol, and this little triangle thing. I'll talk about what each of these actually means in a second, but you can see that that's labeled with multiple items. This one right here is a black jack, and it's just labeled as common. And this one right here is a red jack, and it's labeled DC 10 amps. So if you're only measuring for current and it has a large amperage, then you're going to put the red plug in here. We won't use this one as much in this class. We will, however, use it a little bit when we're working with things like a motor. On the other hand, we're going to use more often this multi-jack. I call this the multi-jack because it has multiple things that it's related to. And you're going to use the red lead, and you're going to plug that into that jack. Then the common, which is the black lead, and that's related to ground, and you're going to plug in the black lead there. Now if we focus in on the values that are around the dial, you'll shift the dial to whatever position that's applicable to what you're measuring. And so right here, this is your battery load test. So that relates to BAT right here on their multi-jack. And that battery load test is used to check whether a battery is good or bad. So you might turn it to 1.5 volts if you're measuring a AA battery and you wanted to see if it was good. And so it would light this checkup if it was good. It would give you the question mark if it's kind of in between, and it would give you an X if it's not a good battery anymore. So that could be useful in this class, in that you might test your batteries that you have connected to your Arduino, and it'll help you know whenever you need to change them out. Now you have DC milliamps, and that's also connected to this multi-jack here. And so the DC milliamps, you would move the dial here if you were wanting to measure current, small values of current, which is what we'll predominantly do in this class. Now if you wanted to measure larger values of current, you would have the multimeter here on the DC 10 amps, and then this lead right here would move to the DC 10 amps. So if you look on this side of the dial, you can see that the first thing we come to is DC volts, and DC volts, we'll use that a lot in this class because that's where we're going to measure our voltage. And then we also have AC volts and AC milliamps. We're not going to use AC very much in this class or at all, so you're not going to use those dial settings. But if you look at this dial setting right here, this should be familiar to you all. That is the symbol for ohm, and that is the unit for resistance. So if you wanted to measure the resistance value of a specific resistor, you can turn the dial here and you can measure its resistance. This right here, triangle and a line, That's going to be used to test diodes. We'll go into more detail what a diode is in a future video, but you can use that to test the diodes. And then this right here, which is a sideways looking Wi-Fi symbol, it's not measuring Wi-Fi. We're going to use that to measure continuity. And that's actually what we're going to use today in order to understand how a breadboard works. So I'm going to turn the dial to continuity, and then I'm going to pull out my Arduino. So everyone should have their Arduino, they're robot built, and you have these wires right here, and you were told just how to connect these. And we didn't really go into a lot of detail about what this was, but you have a black wire here that connects your ground. So if you look right here, you can see the ground for the black wire. It connects it all the way to this blue stripe right here on your breadboard. And then you have the 5 volts, a red wire, and the color of the wire doesn't matter. It's just good to have it use a similar convention of everybody so that you can easily troubleshoot. But you have 5 volts connected to this plus side of your breadboard. And then you should have also connected 2 wires, one from the negative, the blue line to the other blue line on the other side, one from the red line to the red line on the other side. Now these columns right here, these 2 columns right here, are going to be special columns compared to just the field of holes and slots in the regular part of the breadboard. And we'll see that in a minute. So what I want you to do is I want you to get your wire kit out, and I want you to just get 2 wires. Doesn't matter the color, I just want you to have 2 wires. And what I want you to do is kind of straighten them out. And then what I want to do is, let's not look at these columns right here. Let's do these columns last. Let's look at just this field of holes in the main part of the breadboard. And so what I want you to do is take one of the wires and plug it into any row. It doesn't matter what row. I have it plugged into 10. That's kind of nice. They're numbered down the rows and labeled with letters on the columns. And so I have it in row 10. It doesn't matter. You can put it anywhere. And what I want you to do is take your other wire and plug it in any other row. So any other row. So not row 10. Let's plug it into row 15. And what I want to do is I want to test whether or not row 10 and row 15 are connected. And so what we're going to do is we're going to have our multimeter set to continuity. And what continuity measures is, are these connected? It kind of asks that question. So I'm going to take it and I'm going to hook my wire or hook my lead onto one of my wires. And then I'm going to take my other one and hook it to the other wire. And what should happen is, if they're connected, my multimeter should beep. And it didn't beep. That tells me that these 2 rows, 10 and 15, are not connected. What I want you to do next is I want you to pull out the wire, and I want you to just plug it in to different rows and see, okay, well maybe it's these columns, because I had it way over here in 15. Maybe it's these columns. It still doesn't beep. So none of these are connected. None of the columns themselves in this main field area are connected. And then if I move out, they're also not connected. But what if I put my wire in the same row as my initial wire? It beeps. So I know that in this row, these are connected. Okay, well this is row 10, and this is also row 10. Let me check and see, is this row connected to this row? Take a second and take a guess. Do you think they are? All right, let's plug it in. No beep. So that tells me that only these 5 little holes here are connected to one another. But when you jump across this gap, this trough right here, this gap, they're no longer connected. Now if I have this here in row 6, let me ask you, if I move this one over to row 6 right here, will it beep? No. But if I put it in the same side of the gap and on the same row, it will beep. So that's important to know. If I'm building circuits, I need it to be a closed loop. I need everything to be connected to one another. And so I would need to utilize the fact that these rows individually are connected to one another. Now, let's talk about these columns right here. So I said this red column and this blue column are special columns. We call these columns bus strips. And so what they do is allow us to connect a voltage source or connect components together through the whole line. And so let's see how they're connected. If I put this one right here, if I plug this wire in on the red column, will it be connected if I plug this into the blue column? No, it's not, which is good because I don't want it to be. I have this black wire coming from my Arduino plugged up to the blue column, and I have this red wire plugged up to the red column, and so I don't want these two to be connected to one another. But what I do want to do is see that this red, so this 5 volts that's coming from this red wire, I want that 5 volts to initialize all of these pins. So I'm hoping when I plug this wire in down this red column, they're connected, and they are, which is great. Now remember, I took this red wire here and I connected it to this red right here, and so my hope is that this 5 volts coming from the Arduino goes through this red wire, through this column here, and then moves through this wire and down this entire column. So if I plug this wire in all the way on this side, it should still be connected to where this blue wire is plugged in on that red column. So let's see if that happens. And it is. So those are connected, which is great. Same thing with the blue. So if I were to take this and move this to the blue column, and then I were to take my wire here and plugged it to the blue, you would see that these are also connected. And so that ground pin right here from my Arduino is plugged into this blue column. It's all ground through this black wire all the way down this blue column here. And so that will help me later on when I'm building circuits. I'll be able to utilize all these columns here with the red as 5 volts and all these holes right here in the blue column as ground. And so I can build multiple circuits on the same breadboard. One last thing I want to show you is the underneath side of a breadboard, and I think that'll help you visualize how these things are connected just a little bit better. If I flip over this breadboard, so this is one that I pulled off of, I pulled the backing off of. I don't want anybody to pull the backing off of theirs. Be warned, because you will short out your circuits and it won't connect properly. But I do want to show you, look at the metal. So notice, remember we said the rows are all individually connected. If you look at the metal of this breadboard, see how these are representing the rows. So here's a row, here's a row, here's a row. And notice how these are not connected to one another. It's just a single strip of metal for just that row. Jumps over the trough, there's no metal here. And then there's metal for that row. And then when we look at the bus strip itself, you see that there's an entire line of metal that goes down, and then a line of metal that goes down as well. And so, but these are not connected to one another. So individually, this row right here is completely connected, and then individually this row is completely connected, or this column is completely connected, but not to each other. Then when I take that wire and jump these over, it connects this line with this line. So remember this. Remember how the breadboard works when we start building circuits on the breadboard.